All right, good morning, scholars. We're going to be going over section 2.3, real zeros of the polynomial function. Please have out in front of you the handout, which has the prepared notes. And we're going to be starting a new section today. The good news is that you actually have seen some of this material before from Algebra 2, so this would be a nice refresher. And then just making some connections now to what we've been learning in here, which is polynomials. All right, so what will we learn today? We're going to learn how to use long division to divide polynomials by other polynomials. Okay, and you will see the connection today between using long division and graphing polynomials. Long division of polynomials. All right, so check this out right here. Say if we were to consider this this polynomial, 6x cubed minus 19x squared plus 16x minus 4. Notice that right here, I have it graphed. At the x equals 2 value, this is a half, 1, 1.5 at 2. At this value right here, it seems that we have an x-intercept of 2. We have a 0, and it's at 2 right there. Now, so what that means that since f of 2 equals 0, meaning if I plug in 2 into my function, then my y value must be 2. That must be the case because any coordinate point has a y value of 0. So I know that this coordinate point, when I plug in 2, just like it says right here, the y value must be 0. Okay, you know that x equals 2 is a 0 of the polynomial function. And since this is true, since x equals 2 is a root, we also know that x minus 2 must be a factor of this polynomial. We know that x minus 2 is a factor, meaning if I were to multiply the other factors, it would multiply to get its original function. So watch this. Since that's true, then this means that there exists a second degree polynomial, q of x, okay, such that our original function, if you take x minus 2 right here, and if you multiply that by some other polynomial, that's why I'm going to call it q of x. If I multiply it by some other function q of x, these two, if I take their product, must give us back the original function. Hopefully that's making sense. If I take a factor plus multiply it by some other polynomial, it must give us this right here, okay? All right, so now let's go on to example number 1 so that you can see this in action now. All right, so we have the polynomial up here, right? I have the same polynomial, 6x cubed minus 19x squared plus 16x minus 4, okay, which is this polynomial, and we're going to divide by x minus 2. So I'm going to divide by this factor right here, okay, not x equals 2, but remember it's the factor of this. And watch what happens. This is some really neat stuff here. All right, so we're going to set up our long division, and if you recall, so we're going to write this guy first. So 6x cubed minus 19x squared plus 16x minus 4, and we're going to divide this entire thing by x minus 2. Okay, that's how that guy works here. All right, so this is how we start to tackle this guy. We ask ourselves this question. We say x times what are we going to write up here, will give us 6x cubed. X times what is 6x cubed? Wasn't it 6x squared? So I'm going to write the 6x squared right on top of where I had 19x squared, meaning I want these to line up right here, okay? So now that I have this guy, I'm going to go ahead and use the distributive property. 6x squared times x is 6x squared. 6x squared times negative 2 is a negative 12x squared. Okay, so notice I did the distributive property. All right, so just like any long division problem, we're going to go ahead and draw a line right here. Okay, and don't we always subtract these numbers right here? All right, we're going to subtract them, so maybe I'll use a different color here. So this is going to go from a positive to a minus, and this will go from a minus to an addition. And now we're going to go ahead and combine terms. So those guys are gone. And then right here, I'm going to change the color here. And then right here, we'll get negative 7x squared. Okay, negative 19x squared plus 12x squared. All right. So now we always bring down our next term then. We're going to bring that guy down, 16x. And now we're going to do the whole problem all over again, the same process, meaning I'm going to say x times what is negative 7x squared. Okay? X times what is negative 7x squared. So wouldn't that be negative 7x? Right? If I multiply x times negative 7x, I'll get this. All right, so let's multiply. Negative 7x times x is a negative 7x squared. A negative 7x squared. And then negative 7x times a negative 2 is a positive 14x. All right. Actually, I wanted to use my cool little tool thing, make it nice. All right, let's go ahead and subtract these guys then. So we're going to subtract. So we'll change the signs. So it's become a negative to a positive, and this will go from a positive to a negative. So those cross out, and right here we're going to get a positive 2x. Okay, bring this guy down, and we do the whole process all over again. X times what is 2x? X times what is 2x? Well, wouldn't that just be simply a positive 2? X times 2 is 2x. 2 times negative 2 is a negative 4. And so now we're going to go ahead and subtract those two guys. Let's do that. And we're going to find a nice voila. Watch what happens here now. That becomes a minus. That becomes a plus. Voila. Voila. And we get a remainder of 0. If you remember, like, this is where our remainder is. Okay. So over here, I said that we can rewrite our original function as x minus 2 times something. Okay, we just found that something right now. So let me just rewrite this down over here so you can see the connection. So I'm saying f of x is equal to x minus 2 times some polynomial q of x. So what I'm trying to tell you is this, all right? I'm not trying to creep on it. I'm trying to tell you clearly that if I take now x minus 2, and if I multiply that by what I just found right now, okay, which is this guy right here. If I take this guy, and now if I multiply that, what I'm telling you is that we are going to get our original function, 6x squared minus 7x plus 2. Multiply these two guys out right now, and you're going to get back the original function. And this works because this is called a factor, right? And we could also factor this guy right here. So like, for example, we can do x minus 2. Now, if we factor this, let's see, maybe 3x, 2x. Let's see, maybe we'll do 2 here and a 1 there, and then make them both negative. Let's see if that works, though. Let's see. 6x squared minus 6x minus 1x. Oh, no, wait a minute. I want this to be a 1x right here. No, I can't do that. Let's see. Hold on, guys. I'll get this. 6x. Maybe probably 6 and 1. So let's change that. So say if we did this instead, then. So let's say if we did 6x and x, and then if we did 2 and 1, so that gives us 6x, 7, 8. Damn, what the heck? Nope, that didn't work either. I guess I go back to my 3 and 2. I guess I probably just didn't see it there. Sorry, guys. I think I passed algebra when I was younger. But, all right, let's try this again here. So, let's see. 3x and 2x. All right, that gives us our 6x. I want a 2 right here. So, let's see if I do 2 and 1. That'll give us 3x. That'll give us 4x. Good. And then, all right, this is what we want then. All right, cool. And then we'll make these both negative. Okay, so now if I multiply all 3 of these factors out, I'll get back my original function. Okay? So one of the main purposes of long division is you can divide a polynomial by like a binomial, and then you get another factor, which means now then you can find its additional factors, which now we have our polynomial written in factored form.